Okay, so Iosif, CEO and founder of Ethernity Cloud, which is a decentralized confidential computing platform. 20 years of experience, cornerstone tech infrastructure roles at U.S. Department of Defense and Max Planck Digital Library. And today he'll speak about AI and blockchain mix, specifically in the context of science. Thank you, Iosif, for being a great partner and being here.
Thank you very much for the invitation. We made it work, so I'm very happy about it. When I started this project in 2017, I was sharing the same ideas and the concepts and philosophy as my previous speaker. Shelley, the core and the nature of using technology and using the internet and using the Web3 to allow and empower users through a defined set of rules more efficiently and removing intermediaries that create unfairness in the whole world and the rules how they work. This whole concept started with banking, and it affects all areas of life, including science and including technology and compute processing. We picked, because of my background in infrastructure and networks and cloud compute, I decided to do a decentralized compute layer, similarly to what AWS is doing. And because of my connection with Max Planck Digital Library at the time, I decided to make it a use case for scientists to use it properly as well. Then, after building up this ecosystem, which is out there today, and I'm going to present some statistics on it today, the next step is to onboard AI processing on top of it. Why? Because I truly believe, we want AI to be part of our life in everything we do. But there is main concerns and main areas why we are afraid of it. And they're valid concerns. And this is what we tackle with the type of the technology we have developed so far. So we are architecting a groundbreaking technology, a layer on top of EVM blockchains that allows computing of any type, including AI, and it allows a safe processing of information from any system in the world connected to that blockchain. We are looking at making the AI industry safe and efficient without having the users to worry about what happens with my information. Is it fast enough? The AI algorithms are on a brink of explosion. Everybody knows now that AI is being adopted more and more. There's more money thrown on it from a research perspective, but also from a data collection perspective. So that information that happens in the AI space is very, very valuable. That's why everybody's throwing so much money on it. They want to get there, and they want to get the information. Now, from my point of view, I think it's very clear that for this opportunity, we have to be prepared and we have to build the right technologies to maintain our independence from big tech companies. Because they are the ones that are abusing this technology, like the market. So what are the core challenges in the AI space, but scientifically as well? The potential right now, AI has a huge potential, but it's hindered by intellectual property rights. Nobody knows who owns that information that AI is processing, how, who's the right owner, who's like, how is that even fair in a fair way calculated to where the original people that came up creatively with their research, for instance, in this case, are paid fairly from a perspective of having the data fed into it. So we take an approach at a technological level rather than conceptually, but there's projects here today that take level on from a concept level on the top. Most of the scientists are reluctant to sharing their information during their research. So they start researching and everybody's like kind of crunching in a corner, like I don't want to share this with anyone until it's published, and this takes, I don't know, years. Shelly, how much does it take to from writing something to like fully sharing it, publishing it, in most cases?
After data collection?
Yeah.
Depending on complexity, analysis, writing, rewriting, 6 months, depending on
Yeah, 6 months. So even if you have a very good research team, they're afraid of sharing information with each other because somebody could take somebody else's advantage. Only when it's published, then it becomes their thing. So our solution, that's the challenge right now. Everybody wished to share this information while they're doing research, but they can't. The other issue is, let's say, financially. AI processing is very expensive. Hardware costs one video card from NVIDIA 100,000 euros. I understand there's big organizations, scientific, that have access to it, but they, like, I live in Germany, and there, Max Planck Society and everything, they can set up a data center of their own without issues, but it's not. The rest of the world is not like that. I was born in Romania, and I understand how a scientist has to work with less resources. So they cannot use it unless they share the information with Google or, I don't know, Grok, Elon, and who else? Microsoft. So they have to share it with them. So that creates an unfair game from the start. What do we do about it? So our protocol is transparent because it uses blockchain. So all the information that goes through the protocol is hashed and stored on chain, and it's securing AI usage. So as data is collected from wherever environment it comes, it's first hashed and then it's securely processed. Then on chain, there's written proof of results of computation. So assuming you're working on a research yourself and you do some calculation in there, the first time the byte of the information comes up from the computation is hashed and stored under your wallet as you become the owner of that process. On Bloxburg, you also get an NFT that points to this information. Now, this is before you even have it on your computer so you can share it. So it's at the point of first generation, and this is before anyone can get their hands on it. Like, it doesn't matter if the cloud service provider, they don't have access to that information because it runs in a secure enclave. Then the integrity of the whole process, what happens? Who shares with who? Who has access to that information? Everything is done through the blockchain. So everybody can look at the trail on what happened, and based on the blockchain of choice, you can decide, to pay the gas fees. Right now we are on Bloxburg blockchain, which is scientific blockchain. We started working this, but also on Polygon blockchain, and we're slowly expanding to other EVM ecosystems. what is the purpose for the future? So this stuff as a concept is there. There's tools, you can do limited amounts of machine learning today. But we want this training environment to be accessible through blockchain APIs, but also through REST APIs. At the end, the data is protected throughout the process, so it doesn't matter if it passes through an intermediary to facilitate any kind of functions or managing the resources on the network we have. Then optimizing the compute usage. We have a network of over 5,000 operator nodes. They vary from small, let's say, household compute to servers, but big servers, 10,000, 2,000, 20,000 worth of dollars for big hardware. And we're looking at expanding to video cards as well. And we want to optimize the way the AI is being used and built. Then the product will use the layer we had built, which is called a proof of execution layer. This layer processes information safely and allocates the amount of resources, ensuring peak efficiency. We do look at frameworks. There's frameworks for AI done by Google, by OWASPs. The way we build the technology, we design it so it fits in those models. So we're not against, let's say, regulatory aspects. We actually want the regulators to understand how the technology works because it fits their model, and in the end, it protects the users and their privacy when they choose to do so. This is the team. It's me on the left. Then Ioan, it's the COO. He's born and he operates from Romania. And Andreas, he's from Greece, and he has very good background with AI technology and neural networks from over 20 years and has very good connections in the field. Now I want to talk about the technologies we use or the strategic alliances, and here includes a bit also our community. So the first strategic partnership we started is with Intel. Intel has this technology in their chipsets, and they allow areas of, let's say, of the computer to run a process without having the owner of the hardware or anyone with access like a hacker to the system, without being able to look at what's being processed or manipulated. And this is a relatively new technology. It's called confidential computing. They started this, I think, around 2010, and now it's becoming mainstream. Then the second aspect and the second step we took, it's being part of NVIDIA's accelerator program. NVIDIA is also providing this similar type of technology at the level of the chipsets. And we are very happy that we are on board with their program because they can provide the hardware for any of the community members to be able to use and on board on the ecosystem. Then, of course, I'm trying to use my, let's say, connection I built throughout time, but also anyone in the community that we gathered to work use cases for specific fields. So with Max Planck Digital Library, we go into this DeSci area where scientists can use the ecosystem. We have built a module for Jupyter Notebook. It's a tool that scientists use to interpret Python code and then build reports or take notes. And we built a module for that tool, which if you want to use a let's say, a Python server, and you don't want to share your information with the owners of the server, and you want to process it confidentially, you can do it so through our plugin and send it to the network, and the network is processing that information. Then, of course, it's our decentralized network and our decentralized community that comes as a layer of who operates the network. And this is what we have built in the past 2 years, and I'm going to have a slide describing that in a moment. We have over 5,000 nodes that are independent and set up by the community, spread all over the all continents in the world. There is a higher concentration in Eastern Europe, but I think it will grow and will decentralize much, much better. The actual compute capacity is 500 teraflops. That's like a very, it's not a medium-sized data center, that would be like 2,000, but it's a good-sized data center. It's not very small. That's actually a lot of computing power that can be used right now, and the capacity is there. So we are ready to accommodate any, let's say, substantial project that needs computing power. Then we have a staking program, and to see the trust our community has in our ecosystem, you can see that 31% or more, it's being staked throughout the staking program, and 30% of the staking rewards it's already sent out, and the next 60% they'll get sent out throughout the next 3.5 years, decreasing in amounts. The community, it's around 60K members, spread all over like Twitter, Telegram, all over. I'd say it's a good size for where the project is right now. Then we have 2 tokens. One token, it's available on the Bloxberg network. The Bloxberg blockchain, it's a scientific blockchain. It's a proof of authority maintained only by organizations, scientific organizations. And this is where the staking program lives. And this is where we have a lower fees for scientists to process tasks. And there's another token we have, the ECLD token, which is listed for trading on Bitmart and QuickSwap, but other decentralized finance protocols as well. And it's made mostly for commercial applications for various use cases. The partnerships we have, I already spoke about Intel and NVIDIA. Then there's Gauche, there's Jocelyn DAO, MPDL, the Max Planck Digital Library, Jupyter Notebook, Bank of Memories, Confidential Computing Consortium, the Institute for Internet Security, Prevention, and a couple of others which are not yet on this slide. So we're growing this way. At this moment, both blockchain technologies and cloud confidential computing, they're becoming mature enough. And this is the time when products and technologies built on top of it have to be taken seriously, because this is where the actual opportunity is. Of course, in the AI sector, there's a lot of requests for more and more computing power. However, the space is limited in data centers. It's not so easy to build a data center. So if we leverage together the community, time and effort, everybody gets something out of it due to the fairness of the tokenomics of the whole project. So today I'm here to invite you all to be part of this, either by having your own use cases around AI or decentralized science. When this technology used, it's a utility token. Obviously, the demand grows, and obviously, the whole ecosystem grows, so we can grow together based on use cases we have. We do have a grants program, so if anyone makes a serious project around it, sometimes European funds can be used with this type of technology, and we should work together on building it and improving on it, while actually touching very specific use cases that help society from decentralized science, but other areas as well, like healthcare, for instance. Thank you very much. And I'm so glad to be here. Thank you.
Any questions?
Great. Thanks for the presentation, Iosif. What has been the biggest challenge for you in describing to people why decentralized compute, especially for AI, but in the blockchain cloud computing space in general, what has been the biggest challenge for you in communicating that to people? Obviously, in this room, a lot of us are decentralization maxis, but what about to enterprise clients or people from traditional academia or even traditional infra?
So the same way as in science, like Shelley explained, there is a hallucination happening in the mind of the collective that their data is safe. That's a big lie. It's just a matter of time until people realize that's where the lie is. Now, there's a lot of money being invested in making everything more and more secure. The problem is there's more data generated every day, and then there's less prepared people, experts. Small amounts, experts are shrinking, the amount of data is growing. So obviously, we need to take a measure at the cell of the whole ecosystem, if you think it about like the internet and everything works, which is the data itself. Before, like in the 90s, you wouldn't have encryption on your email account. Like everybody would email. Like some people did, but the ones that knew what this is and how is it useful. But most of them, they would just send it unencrypted. And also when you store it, you wouldn't encrypt your thumb drive or the first time it existed. But today, the technology is to have it encrypted while it's running, which we haven't had a few years back or is still testing. So now you can encrypt the data while it's being processed. And this, people don't really understand. This is actually something new and brilliant. And this, connected with the transparency of the blockchain, can guarantee a level of security for the information, and you can establish a whole new design around these technologies that bring the best of the world, so to say, and protect the data at the cell level. There's so much money spent on infrastructure. So you have the data circulating throughout infrastructure. You put a lot of money on the infrastructure to protect it, all type of security measures, and then the data is still exposed in the infrastructure. And then if somebody leaks it, right, then everybody wants to cover it up. Because nobody wants to say, hey, Google got hacked or this guy got hacked. And you have, news lines like, I don't want to bash any company, but there's like a big car ride company that had their database hacked, and they covered it up, and then they had to pay hundreds of millions or something in the US, and that's before GDPR was even a thing in Europe. So just thinking now about the exposure, like everybody's covering it up and everybody knows it's happening. It's just a war, right? Like it's happening. So I'm from the side of taking the best measures to protect it as a concept and as a design, from a design perspective. I hope this covers the answer.